Right. G'day mates. Welcome to the Smart Video Lab. We're going to be looking today at some linear functions review. This is off the EOC review, linear functions versus exponential functions versus quadratic functions. I'm going to make 3 videos, this being the first. So first we're going to talk about linear functions. I'm actually going to start on the page that you're given in class. It starts with standard form and then it goes to point slope form and then a slope intercept, but for the video I'm going to jump on down to slope intercept. So if you're following along on your sheet, go ahead and look at slope intercept form. So again, slope intercept form for a linear function, because remember the big category here is still linear functions, is y equals mx plus b, where m is the slope and b is the y-intercept. So example 1, what is the function rule for a line with a slope of -3 and a y-intercept of 5? Well, that's easy peasy. Y equals -3x plus 5. The slope -3 goes in for m, and the y-intercept of 5 goes in for b in the function rule form. Y equals mx plus b. So y equals -3x plus 5. Example 2 extends this concept to a word problem. Ralphie, that's my dad's name just in case you're curious, wants to buy a skateboard. But first he has to pay back $25 to his brother. He gets a job making $8.50 an hour. Write a function rule that represents the amount of money he has earned based on the number of hours he has worked. So we know it's going to be of this form, y equals mx plus b, that we're talking about up here. The question is, what's m and what's b? Well, $8.50 an hour represents our slope. That's the rate of change, the amount he's making per hour. So it's going to be y equals 850x. Now, he owes his brother $25, so he has to subtract $25 from whatever amount he makes. So the equation is y equals 850x minus 25. Okay, now looking at standard form. So I could take any linear function and I could write it in this form, slope-intercept form, like we did here, or I could write it in standard form. So this standard form, x and y are on the same side. ax plus by equals c, where a, b, and c are constants. So here's an example of standard form. 2x plus 4y equals 14. X and y are on the same side. Question is, what are the slope and y-intercept of the line 2x plus 4y equals 14? And this is why I started with slope-intercept form, because whenever a function's in that form, it's easy to tell what its slope and y-intercept are. That's why they call it slope-intercept form. So I'm going to convert this standard form line equation into slope-intercept form. In other words, I'm going to solve for y. So to do that, I'll first subtract 2x from both sides. Remember, 14 and -2x are not like terms. So I get 4y equals 14 minus 2x. And then I need to, that commercial break brought to you by Lenovo ThinkVantage Toolbox. So anyways, here we are. We're solving for y. We subtracted 2x from both sides. 4y equals 14 minus 2x, and I'm going to divide both sides of the equation by 4. So I get y equals, let me think about this in the cloud over here, 14 over 4, that simplifies to 7 over 2, so y equals 7 over 2, and then 2 over 4, that's 1/2 x. So the slope is -1/2, and the y-intercept is 7 over 2, or 3.5. If I write that as a point, the value of x at all y-intercepts is 0, so it would be 0, 3.5 if I wrote it as a point. Alright, the next question says, what are the x-intercept and the y-intercept of the line 3x minus 5y equals 30? So let's look first at the x-intercept. Now think about an xy axis. And think about a bunch of x-intercepts. All of these our x-intercepts. Now, all of them have different x values, but they also all have the same y value. So what is the y value all along that x-axis at any of those points? That's right, the y value is 0. So to find my x-intercept, I substitute 0 for y in the equation. So I am left with an equation that's just based in x, because 5 times 0 is 0, so I'm just left with 3x equals 30. Divide both sides by 3, and I get x equals 10. So that's the point 10 comma 0 is my x-intercept for this graph. Let's talk now about the y-intercept. Now, all along the y-axis at these different y-intercepts, what's the value of x? That's right, it's 0. So this time 0 goes in for x in the equation, and I solve for y. Divide both sides by -5, and y equals -6. So that's the point 0 comma -6. Now it should make sense, right? When I was solving for the x-intercept, I ended up getting an x value, and y was 0. When I was solving for the y-intercept, I ended up getting a y value, and x was 0. Now, interestingly enough, this question doesn't ask us to do this, but we could use those values to help us draw the graph of this equation. So I could start here, and all this stuff is popping up in the way. I could say, let's go by 2's, 2, 4, 6, 8, 10, and -2, 4, 6, 8, 10, and +2, 4, 6, 8, 10, and -2, 4, 6, 8, 10. So this would have x-intercept at 10 comma 0, so that's out here. Y-intercept at 0, -6, so that'd be down here, and I could use that to help me draw the line. So that's just a cool added bonus. That bit was free. Merry Christmas. Okay, now last form that we want to talk about, and this has its uses. It's not as common as slope-intercept form, which is the most common, but it's valuable to know. So again, we're always talking about lines here. These are different ways of representing lines, and you can represent the same line in many different ways. So example 1 says, what is the y-intercept of a line that passes through the point 4 comma -5 and has a slope of -2? So we're going to use point slope form, which is outlined up here. Y minus y1 equals m times x minus x1, where m is the slope, x1 and y1 are the coordinates of a point on the line. So y minus y1, y1 comes from this, so that's y minus -5 equals m, the slope, -2 times x minus x1, which is 4. So simplifying y minus -5, that's y plus 5 equals, I'm going to distribute here, -2x plus 8. Why did I distribute? Because I want to know what is the y-intercept, which means I need to convert this from this form, which it was easy to write it in based on the given information, into slope-intercept form, which means I need to solve for y. So all that's left to do, subtract 5 from both sides. We get y equals -2x plus 3. So the y-intercept is 3. Or if I were to write that as a point, 0, 3. All right, now let's see how this is useful in the real life, out there in the real world, at maybe a movie theater. So example 2. A movie theater sold 65 tickets in a single day and made $215. On another day, the theater sold 25 tickets and made $95. Every day they start with the same amount in the register, and ticket prices are always the same. How much is in the register at the beginning of a day? So the key about this problem is that I'm giving two pairs of information. 65 tickets in a single day makes $215. That's 65, comma 215. 25 tickets made $95. That's the point. 25, comma 95. Now, based on this information, I only need 2 points to be able to create an equation of a line or a function rule for a line. So we have to pick among the 3 forms. We can use slope-intercept, point slope, or standard form. And it's possible to use all of them, but whenever you're given 2 points, in my opinion, it's easiest to use y equals mx plus b, which is point slope form, slope-intercept form, or point slope form, y minus y1 equals m times x minus x1. And my personal favorite, this is just my preference. I need to really stop pressing that. Another commercial break brought to you by the Lenovo ThinkVantage Toolbox. My personal preference is to use this form. So let's do that. I'm going to use this point as well. It doesn't matter which point you pick. It's up to you. So y minus y1, 215, equals the slope. Whoop, I don't know the slope. So I got to backtrack and figure that out. So remember, slope, when you're given 2 points, is y2 minus y1 over x2 minus x1. So that's 215 minus 95 divided by 65 minus 25. And that simplifies to 120 over 40, which is 3. So the slope is 3 times x minus x1, which is 65. Now, I want to know how much is in the register at the beginning of the day, aka the starting value, aka the b in y equals mx plus b form. So I'm going to convert this now into y equals mx plus b slope-intercept form. So I distribute y minus 215 equals 3x minus 195. Add 215 to both sides, and you get y equals 3x plus 20. So the starting value comes from the y-intercept of this function rule written in slope-intercept form, which is $20 in the register at the beginning of the day. And there's other ways you could figure this problem out. That's just the way that I chose to do it. Alright, so last up, we're going to do some mixed review of linear functions. So we want to solve the system of equations by graphing. Whenever you're graphing, you need to first convert to y equals mx plus b slope-intercept form. That's the best way to do it. So let's graph this line. We need to solve for y. So first I'm going to subtract x from both sides. Negative 2y equals 7 minus x. Now I divide both sides by negative 2, and I get y equals 1/2 x minus 3.5, because 7 over 2 is 3.5. Now the other equation, actually let's graph that equation first. So it starts at negative 3.5 down here at the y-intercept, and the slope is 1/2. So remember, slope on a graph is seen as rise over run. So I rise 1 and I run 2. And I plot that point. Rise 1, run 2, rise 1, run 2. In the other direction, down 1, left 2, and I can draw a rough line. My straight skills aren't the best. Hopefully yours are better. So now I want to solve this equation as well for y. So if I subtract 2x from both sides, I get negative y equals negative 2x minus 1. And then dividing both sides by negative 1, I get y equals 2x plus 1. And I can graph that. So it starts at 1, slope is 2, so up 1, 2 over 1, 1, 2 over 1, down 1, 2, left 1, down 1, 2, left 1. So as I draw that line, that's a miserable fail. And I'm looking for the place where they intersect. And it looks like, again, my drawings aren't perfect. I should have used a ruler. It looks like they intersect right there, which is -3, -5. So you could graph both of these equations in your calculator, find the intersection to be sure, or we can check and see if they satisfy these equations here, which is what I'm going to do. So first off, x minus 2y equals 7. X is -3 minus 2 times -5, because y is -5 equals 7. Is that true? -3 plus 10, does that equal 7? Yes, 7 equals 7. So that works. Now the second equation, 2x minus y equals -1. X is -3, y is -5. 2 times -3 is -6, minus -5 is like +5. Is -6 plus 5 equal to -1? Yes, it is. So that point does in fact work. It is the solution to the system of equations. Thank you for watching this video. Come back and see me for exponential functions review. Much love and toodles.